But we're going to look more into classifying triangles using the Pythagorean theorem. Okay, so what a converse is, first off, is if I have 6 plus 5 equals 11, then you can also read it backwards. Okay, so I could also say 11 is equal to 5 plus 6. Okay, so it's just a backward statement of the original. So then the converse of the Pythagorean theorem states if we have a squared plus b squared equals c squared, then you have a right triangle where c is the longest side. Okay, so if you have this equal to sign here, you have to have that 90-degree angle, making it a right triangle, where C is the hypotenuse of that right triangle. It is also the longest side. So we can use that converse to classify a triangle as acute, obtuse, or right. Okay, so these are different classifications for a triangle. We have a right triangle, an acute triangle, and an obtuse triangle. So using the Pythagorean theorem, or the converse of the Pythagorean theorem, if it is a right triangle, we will have c squared is equal to a squared plus b squared. Okay, so that part is important. Okay, that one has to be equal to. Okay, again, where c is going to be the longest side. Okay, and you can see that in our triangle below here. This c value right here is the longest side of that right triangle, and you have that 90-degree angle to show it is a right triangle. The next one is an acute triangle. Okay, in an acute triangle, your c squared value will be less than a squared plus b squared. Okay, so that's an inequality symbol. That one reads less than. So your longest side, or your c value squared, is less than your other two sides squared and added together. And again, c is the longest side. So in all of these, c will be the longest side, and you will have to locate that side to know what that c value is. Okay, the last classification is an obtuse triangle. In this one, your c squared value is greater than a squared plus b squared. Okay, so that side squared, that number you get, will be greater than your other two sides squared and added together. And again, c is still the longest side. Okay, so our pictures here, this is what an acute triangle looks like. All of your angles are less than 90 degrees. Excuse me. In an obtuse triangle, you do have one angle that is greater than 90 degrees. Okay, questions before I do some examples, and I think it'll make a little more sense once we do those examples. All right, then if you go to the bottom here, we want to classify each triangle as acute, right, or obtuse. So for number one, we're going to do this one together. The first thing I do is locate my c value, which is the longest side. Okay, so your largest number. Okay, so number one, my longest side is this 16 right here, because these three are side lengths of a triangle. So this one I would label as C. Now just like before, your A and B values, those you can interchange. It doesn't matter which one you label A, doesn't matter which one you label B. But for our purposes, I'm just going to label 7 as A and 14 as B. Now when I set this up, I want to write my C value first. Okay, it'll be a little bit easier to read if I write it first. So I'm using this equation again. Okay, it's just the Pythagorean theorem, but I'm going to start with C. So we have 16 squared. And now we're not going to write equals. Okay, we're not going to write equals. We're going to compare it. So I'm going to draw in this like blank space. Okay, this blank space, because I want to compare the two sides of my equation. And then I'll write my a squared value, which is 7, plus my b squared value, which is 14. So again, you will need a calculator. So from here, all I'm going to do is square my values and then add the right side together. So 16 squared is 256. Again, I'm going to compare my answers. Then I also have 7 squared, which is 49, and 14 squared is 196. Okay, so next I'm going to just add the right side together. So we have 256 compared to 245. So this is where that equal sign or one of those inequalities comes into play. So which side is bigger? Left or right?
Left.
Left.
Come on.
Okay, so your bigger side is whatever side it opens up to. Okay? So your inequality opens up to the bigger side. So now what I'm going to do, since I have 256 is greater than 245, I'm going to look at my chart here. I have my greater than symbol here, so this must be an obtuse triangle. Okay, so that's why I want to start with my C value first. That way, whichever way I write my inequality here, it's the same way up here. Okay, so this is an obtuse triangle. Questions? All right, I want you guys to do number 2. Just number 2.
So the middle number is always C.
No. The largest one is always C. That was a good question, though.
And not everyone's yelling at me for it.
It's okay. They're just reminding you.
Very violently.
Mm-mm.
Yes, I'm curious. Maybe I am, Hannah. You're probably right.
Oh shit.
Bro, just kick her from the.
You want to give me a calculator?
Sure. You want to come to my game tomorrow?
Where at?
Here in Richmond. 4:30. What time do you get done? Damn. I think we have a game in Final Line.
I mean, Hannah, you're probably right since my
It's
mom has
varsity and
bipolar.
JV plays over at English. Not English, over at Murray.
Hey, hey,
It's not like I've been
Can we
diagnosed with
stop?
anxiety.
Yeah.
can we stop? Can we just do number 2, please? That's all I want you to do.
I'll get back to you though, just to make sure.
Well, Hannah's
I know. Let it go. Just do number 2.
I already did.
Okay, good.
It's 1681 equals 1681.
All right, so we're going to keep going here. We're going to keep going here.
Which is a right triangle.
So, number 2, First step again is to locate your C value. That's always the largest number or the longest side. Okay, so that is 41. And that's my C value. Now again, A and B can be interchangeable. So I have A and B. If you flip-flop them, it's fine. You'll get the same answer. So setting up my converse of the Pythagorean theorem here, I always write my C squared value first, which is 41, and that's squared. I want to compare that to 9 squared plus 40 squared. Okay, so 41 squared is 1,681. Okay, that's compared to 9 squared is 81, plus 40 squared is 1,600. Okay, so I just want to add those two together. So I have 1,681 compared to 1,681. They are equal. So if I look at my chart up here, the one that's equal to is a right triangle. How do we do on number 2? Yeah. Max, face forward, please. Thank you. All right, so looking at number 3. Number 3 has radical symbols in it. Okay, those are those square root symbols. So we're going to kind of look at this the same. You guys all took my calculators. Shh, quiet. So to find your longest side, my suggestion to you is to actually plug each of those into your calculator. Okay, so we're going to plug in the square root of 5 first. So plug in the square root of 5 into your calculator, get that decimal, do not write it down.
Why not?
Because I want you to keep it in the square root symbol when we actually write it as an equation. Okay, so when you plug in the square root of 5, you get about 2.2, right? Okay, remember that. You get about 2.2. Next, plug in the square root of 12. You get about 3.5. Is that larger than 2.2? So right now, that is my biggest side. I still have to check square root of 13, though.
Actually, 3.03.
What?
Square root of 12, 3.03.
It's 3.5.
Oh.
Okay, square root of 13 is about 3.6, which is larger than 3.5. Okay, so now that I know which one of my values here is the largest, that square root of 13 is my C value. Okay, so to check which one is the largest, if you have that square root symbol, plug them all into your calculator, see which one gives you the largest decimal. Does that make sense? But don't write those decimals down, because I don't want you to plug those into the Pythagorean theorem. And you'll see why in a minute. So now that I know what my C value is, again, A and B, interchangeable. I can just label whichever. Now I always want to start with my C value first. So I have the square root of 13. I'm going to put parentheses around it. That is squared. Okay, so I have the square root of 13 squared compared to the square root of 5 squared plus the square root of 12 squared. What happens when I square square root? They cancel each other out, right? That's why I didn't want you to write a decimal. Because this square cancels out that square root, and you're left with 13. Compared to, again, square canceling out my square root, 5. Plus, again, canceling out 12. See how much easier that makes it rather than writing out a long decimal? So now I can just add 5 and 12 together.
Infinity cube triangle.
Okay, that's 17. Now 17 is greater than 13, so again, your inequality opens up to the greater number. So this reads 13 is less than 17, so I want to look for that inequality symbol up here. It is this one, making it an acute triangle. Questions on how I did number 3? All right, we're going to do number 4. So just like we plugged in our square roots into our calculator to see which one is greater, you're going to do the same thing with these ones. Okay, so in your calculator, plug in 2 times the square root of 3. You get about 3.5?
Yep.
Okay, next, 4 times the square root of 4. Should get 8. That one's greater so far, right? Okay, next is 3 times the square root of 5.
6.7.
That is 6.7. So which one is my greater one?
4.
Good job. So that will be my C value. Okay, then the other two are A and B. Now, just like I did in number 3, I'm going to put parentheses around that entire quantity. Excuse me. So first off, starting with C, we have 4, square root of 4, squared.
Let me guess, they'll equal the same number.
Only kind of. Next, we're comparing our A squared value, so 2 square root of 3 squared, plus 3 square root of 5 squared. Now with this one, you have to be careful. Okay, yes, your square and your root cancel each other out just like they did before, but you have this constant or number on the outside of your radical or square root symbol.
So that one that
Okay.
equals 16.
Yes. So you do have to distribute this square to both of these numbers. So I have 4 squared and the square root of 4 squared. Okay, so I have 4 squared, which is 16, times the square root of 4 squared, which is what? 4. Okay, that's where that root cancels out with that square. Okay, so now I'm comparing to, again, distribute your square to both numbers. Okay, so 2 squared is 4. The square root of 3 squared is 3. And again, these are multiplied together. Okay, that's why I'm putting parentheses around it. Last one here, we have 3 squared is 9 times the square root of 5 squared
5.
is 5.
And then we just multiply those together.
And then you multiply them together. So we have 16 times 4. That's 64. Okay, 4 times 3 is 12. 9 times 5 is 45. And now all I have to do is add these two together here. So we have 64 compared to 57.
That's an obtuse thing.
Okay, so 64 is greater. Again, it opens up to that greater side. So I should look up at the top to see which one of these triangles that is. And it is an obtuse triangle.
Kind of like what we did yesterday, just with one extra step.
All right, questions? What time are we done here? 87? Okay. All right.
It's fine next.
How do we feel about the Pythagorean theorem? Thumbs up or thumbs down or thumbs sideways? Go. Not just about what we did today, Pythagorean theorem in general, what we did yesterday too. Okay, okay.
I love Pythagorean theorem. I'm good at it.
Okay. So if you were a thumbs down, make sure you see me. If you were a thumbs sideways, make sure you're asking questions. If you were good, then you're good. We're going to do number 7.
Because number 6 and or number 5 and 6 were yesterday.
Yeah.
Okay.
So number 7. Hey, shh, paying attention. This one's a little bit more challenging. It's still using the Pythagorean theorem, however. Okay, so we want to solve for our x. Okay, I have 2 x's in this. I need to identify my hypotenuse. How do I do that?
You gotta find the right angle, and then you gotta go to the other leg.
Go across. Yep. So from that 90-degree angle, hypotenuse is across or to the other side. That is your C value in a right triangle. Okay, so in this one, we're not determining if it is a right triangle or if it is acute or obtuse. We're just finding x using the Pythagorean theorem because we know it is a right triangle. Now my other 2 sides are A and B. Again, interchangeable. Doesn't matter which is which. So from here, I'm just going to use the Pythagorean theorem to solve. So I can plug each of these in. So my A value is 9. That's squared. Plus my B value, I'm going to put parentheses around. Okay, my B value is x minus 3, and that quantity is squared. Okay, that's equal to, our C value is x, and that's squared. Now before I continue, what is different about this quantity squared compared to this quantity squared? Talk to the person sitting next to you.
Because we don't know the identified number for x for the one on the back. And in the front, we know the identified number on the front. So, if you square root a negative, wouldn't it be a positive?
Can't take the square root of a negative.
No, I meant like negative 3.
Oh, if you square it,
Yes!
it'd be positive, yes.
Sorry, I got my words mixed up.
All right, so I heard a couple different things.
We have an
So,
identified number for x.
well, yes, you don't know what x is.
I meant for the...
But what's different about this is it has this subtraction here. Okay, in our other side, these aren't subtracted, they're multiplied together. Okay, if I have addition or subtraction within my parentheses, I cannot distribute my square. That is not how that works. This is not x squared plus 9. Do you remember what you have to do?
You gotta divide.
That was good.
Like 1/3.
So I'm going to take this quantity over to the side here.
Oh boy.
What this square means is you're taking that quantity and multiplying by itself. Okay? You take that quantity, multiply by the same quantity.
So negative 9.
So x minus 3 times x minus 3. Does that look familiar?
Yeah.
You need to FOIL this. Okay, so your first terms, your outer terms, I'm going to run into my FOIL. Your inner terms and your last terms. Okay, so x times x is x squared. My last terms, x times negative 3 minus 3x. Negative 3 times x is negative 3x. And negative 3 times negative 3 is positive 9. So once I actually square this quantity, I end up with x squared minus 6x plus 9. Now this wasn't the answer I was looking for. I need to bring this back over to my original problem. Okay, so here, coming back, I have 9 squared. That's 81. Plus, this is where I'm bringing this quantity back here. I have x squared minus 6x plus 9. And again, that's equal to x squared. All right, first thing I'm going to do, I'm going to subtract x squared from both sides. What happens?
You no longer have a c.
You can do 81 plus 9, yep. But since I'm solving for x, I just want all of my x's on one side of my equation, right? Yes?
Mm-hmm.
So if I subtract x squared from this side, I have to do it to that side. But then both sides cancel out. That makes our problem easier to solve. So now what I have left is 81 minus 6x plus 9. And this is equal to 0. Okay, those canceled out. They equal 0.
I think I know how to do the rest of this.
Okay, now I can add together 81 and 9. That's 90.
And then don't you divide the 6x with the 90?
You will, yeah. I'm going to add 6x to both sides so that I end up with 90 is equal to 6x.
And then you divide.
And then I can divide both sides by 6 to get x by itself.
And that would equal. Hold on. Darn. I was going to mental math that one.
So with this one, you do need to FOIL that out. So that's why I put those parentheses around it. Okay, is that coming back to you? FOIL, solving an equation, yes? Yes?